Mobile and Web App Development. Welcome to our crash course on mobile and web application development. We'll start this course by talking about the engine driving India's economic growth, the IT and ITES sectors. Later, we'll talk about their subsectors, web and mobile app development, skills required in these sectors, real-life use cases of these technologies, career paths, and more. First, the basics. IT, or information technology, focuses on creating and managing software and hardware. ITES, or information technology-enabled services, is a field where tech meets service. Basically, it focuses on using IT to improve business efficiency. A massive part of this is the BPM, or Business Process Management sector, where India shines globally by handling outsourced operations like customer support and finance. Now let's look at where you can build a career. The IT/ITES industry is divided into distinct subsectors with global players operating in each space. First, we have the builders in software, web, and mobile app development. You will see giants like Tata Consultancy Services, TCS, leading the charge here with massive software and consulting operations. Next is BPM and IT consulting. Companies like Infosys and Tech Mahindra dominate this space, handling critical business processes and specialized telecommunication services for clients worldwide. Then we have the infrastructure layer with cloud computing services and IT infrastructure management. This is the playground of Amazon Web Services, AWS, which provides the backbone for modern applications. Finally, supporting it all is system integration and specialized hardware. Industry leaders like Cisco Systems drive the networking hardware and software that keeps the world connected. We have identified critical trends in the future skills domain that are directly reshaping your job description: automation and AI integration. It's not just about coding anymore. The trend is leaning toward intelligent technologies. The impact: you will need skills in AI, machine learning, and algorithm development to collaborate with these systems. Remote work and digital collaboration. The modern office has gone digital, and teams are distributed in different geographies. This means you must master virtual collaboration tools and digital project management. Data-driven decisions. Companies are now obsessed with data. This means every role now requires data analytics skills to interpret complex sets of information and make informed decisions. Cybersecurity emphasis. With rising threats in the cyberspace, security isn't just for specialists, it's for everyone. The impact is a universal demand for cybersecurity awareness to protect digital assets. Sustainability and human-centric design. The focus is not just on the business, but also on the users and the planet. This drives demand for professionals who can design intuitive UI/UX and integrate eco-friendly, sustainable practices into their tech solutions. The changes in IT/ITES sector is also shaping the landscape of web and mobile app development. Nowadays, we are seeing a fundamental shift in how we build applications. 1. From sequential to agile, we have moved away from slow sequential development to agile methodologies, allowing for quicker project delivery. 2. User-centric design. It's no longer just about features. The focus has shifted entirely to user-centric design, which prioritizes user experience above everything else. 3. Cross-platform dominance. We aren't just building native apps anymore. The rise of cross-platform frameworks means that we are building unified apps for multiple devices at once. 4. Architecture shift. We are transitioning from massive monolithic architectures to microservices, which makes applications modular and scalable. So, where does this leave you? As an application developer for web and mobile, your career path is diverse. You can specialize in several high-demand roles. Full stack developer, where you master both the front-end visuals and the back-end logic. Mobile app developer, where you can specialize in creating seamless experiences, specifically for iOS or Android. UI/UX developer, where you focus on the creative side, building visually appealing and user-friendly interfaces. DevOps engineer. If you love automation, this role involves managing the continuous integration and deployment pipelines. Technical lead or architect. Eventually, you can progress to leadership, guiding teams, and shaping the technical strategy for major projects. In the previous chapter, we explored the web and web app development. Now, let's shift our focus and dive deep into the world of mobile technology. Mobile technology isn't just about the smartphone in your pocket. It is a complete ecosystem that allows computing on the go. It consists of three critical components. 1. Hardware. This includes smartphones, tablets, and increasingly wearable devices like smartwatches. 2. Software. This is the soul of the device, the operating systems and the applications that run on them. 3. Communication networks, the invisible infrastructure, cellular networks like 4G and 5G and Wi-Fi, that keeps these devices connected to the world. Together, these create a platform where data travels with the user, not the other way around. If you want to build for this world, you need to know the playing field. There are two dominant native platforms. iOS by Apple. It's known for its closed, secure ecosystem and high user engagement. Android by Google. It's an open platform that powers a massive diversity of devices globally on hardware by a variety of device makers such as Samsung, Xiaomi, and even Nokia. Developers today rarely stick to just one platform. We are seeing the rise of cross-platform frameworks like Flutter and React Native. These frameworks allow developers to write code once and deploy it to both Apple and Android devices simultaneously, saving massive amount of time and money. The mobile landscape is evolving at breakneck speed. We aren't just sending texts anymore, we are living in an era of ubiquitous connectivity. Three major trends are reshaping the connectivity space. 1. 5G technology. It's not just faster internet. It enables real-time data transfer for things like autonomous cars and remote surgery. 2. Internet of Things, IoT. Your phone is becoming the remote control for the world, connecting to smart home devices, wearables, and even industrial machines. 3. AI integration. Our devices are getting smarter, using on-device AI for everything from voice assistants to predictive text and facial recognition. Here's an important question for you. Why are businesses pouring billions into mobile technology? Well, there are three important factors driving this growth. Operational efficiency. Mobile apps allow employees to work from anywhere, accessing real-time data and collaborating instantly. Customer engagement. Businesses can now live in their customers' pockets, offering personalized notifications and instant support. New revenue streams. From in-app purchases to mobile banking, mobile technology has opened entirely new ways to make money that didn't exist a decade ago. It is no longer an option. A mobile-first strategy is a requirement for survival. Mobile technology has hundreds of use cases in the present world. Beyond smartphones and tablets, mobile technology is being deployed across sectors. Here are some of its top real-world use cases. In healthcare, mobile tech enables telemedicine and remote patient monitoring through wearables. In finance, mobile banking and digital wallets like UPI have revolutionized how we pay. In retail, augmented reality apps let you try on clothes or see furniture in your home before you buy. And in education, mobile learning apps have democratized access to knowledge globally. In essence, you are learning to build the tools that power these critical human interactions. Until now, we've talked about building apps and the importance of mobile technology. Now let's learn how to protect the data, which is the soul of modern technology. In a global digital economy, following data management standards isn't optional, it's the law. So, everyone must respect four core principles of data management standards. 1. Data integrity. It ensures accuracy and consistency throughout the data's lifecycle. 2. Confidentiality. It focuses on safeguarding sensitive info from unauthorized access using tools like encryption. 3. Availability. It ensures that data is accessible when needed through backups and recovery plans. 4. Compliance. It focuses on adhering to laws like GDPR or HIPAA. To put it simply, data management standards are all about data governance, which is all about establishing clear policies on who can access and modify data. Data management is governed by a bunch of actors. Understanding the role of these actors is essential to comply with data management regulations. Here are these key actors and their roles.